Hey everyone, I was working on the bottom part of the south side of Walkersville and just finding an equation to fit this curve here. Of course, it's not a function, so I'm not going to find a perfect function because of this area right here. Yeah, that area right down there and a few others where it doesn't pass through a vertical line test. But yeah, that's all right. I'm going to get a good approximation here. And I just want to show a few things. First of all, the scale feature I have this, and I'll share this with you guys. Use this to check your map scale. One thing is I have these lines just so I could match this up with the 1 mile marker or whatever yours is measured. Of course, I drag this here, and that way all my units, you know, when I have that here, all my units are, I mean, from 0 to 1, that's 1 mile, right? So if I calculate the area, that'd be 1 square mile. So it's very handy. It's all aligned. If this says, say, like 200 feet instead, you're going to want to change this to 200. Now you have to zoom out a bunch, but you could change this to 200 and zoom out really far. And then this +1 is just what makes the length of that. You can figure out how that works. But yeah, that makes it, now my map scale is 1 to 1. So that means 1 mile here. So this 3 over here represents 3 miles from the origin. So that helps. But yeah, so first thing I want to do is I want to make a table of the points to kind of fit here, and then we're going to find a polynomial best fit. Okay, so if I make a table, I'm going to make some points. Let's just go 0, 1, 2, 3, 4, 5. You know, it looks like I might want 1, 2, 3, 4, 5, 6, 7, 8, 9, maybe 10 points. Okay, so I'm going to go down here, 0 to 9, that's 10 points. I'm just going to make 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 as well. And these points, if I click and hold here, I can make these points draggable. Whoops, well, disappeared. Let's make this draggable here. And now each of these points I can actually move. Oh, I didn't mean to move them. Oh, whatever. We'll grab these. So I want to drag them all back here. I didn't mean for them to be quite so far away. But let's all drag them down here. And I will make them, there's a lot of points there. I'm going to fit them as close as I can to where I want down here. Once we can zoom in. I think that was all. Okay. Alright, so let's zoom in here. So I want one to start on the x-axis here. Notice I want each point to be further to the right than the last point, because otherwise it's not going to be a well-defined function, right? So I got some points there. So I'd like to drag one there, but I just can't, because what will happen is the function is vertically defined, so it'll jump up and down real fast. But let's just try to get this to fit well here. Did I count the right number of points? Do I need one more? That's okay. I can just come down here and type in, let's see, approximate it. It's like about 1.8 comma 0, maybe a little further left. Actually, let's make one more past that. And notice you can get as accurate as you want with these. I'm going to push this in a little bit because I know that a function will cut that off right there. I'd like to be, just honest to how close we are. So that's 1.65, it's more 1.75 rather, 0, there we go. That's pretty good there. Notice I'm pretty close here. I hedged in here a little bit just because I know I'm going to get that, so I'm trying to compensate this out here. But I can make the equation, and we'll be able to see what it really looks like. So with your equation in Desmos, notice, oops, I made a bunch of tables. Y7, X7. Your first one will be Y1. But as you make more tables, then it'll just raise that number there and get more of those. So I'm going to type in Y7 because I'm trying to make a function based on the Y value. And so this is going to make a regression equation, right? So I'd put tilde, and then I'm going to type in, I'm going to use B because I already used A, and I'm going to just type B0 and it makes B sub 0. This way you can have a bunch of variables, B0, B1, B2, B3. So B0 is like our constant, right? And we're just going to keep adding. Let's now do B1, X1, okay? And then B2, X2 squared. And if you look, where's our function? The graph somewhere. Let's keep going. I'm not sure. Oh, not X1. Sorry, that's why. I want X7. Yeah, these are X7. It's different. There we go. Okay, you see. So this is a parabola that is trying to fit this data, right? Not doing a great job because we have a lot of points, right? I mean, it's doing as good a job as it can. It's a computer. But yeah, we're going to increase the degree of this just to make it more and more accurate, right? So there we go. Cubic's a little bit better. Plus B4 x7 to the 4th power. And notice when I start with b0, that's really x to the 0 power. That's our constant here, right? That's going to be that value right there. And the more of these you do, the more accurate it gets. So I'm going to keep going until I get a nice curve up there. You can keep going and make it more and more accurate. But after a certain point, it stops being more, it stops getting more accurate. In fact, what you can do, you can use copy and paste. Just copy that last one. Let's just change the 5s to 6s. And you notice it's getting a little better. Make it look a little better. Paste, change the 5s or whatever number it is to 7s now. 7. Get a little better. Let's do one more at least. I'd like to really get it to dip up there. There we go. Okay, so that's actually pretty good. Notice we are going to cut off at the x-axis, so I can come in here just visually and say, all right, let's make y less than 0. Oh, not y, y7, I guess. That's not going to work. Okay, let's define it for x. Okay, so I'm going to cut it off from, what is this one? This is negative 0.67. So we have negative 0.67 is less than x, which is less than, oh, you know what? I don't think it's going to like this. Okay, 0.75. All right, that's supposed to define the function. Well, here we go. I'm just going to leave it there. So we really don't care about the function outside of these, right? I'm just care about in between these. Maybe I want to increase the degree a little more to make it fit these, but just for the sake, oh, you know what, over here, I do need to increase it a little bit. Let's just get going at least 1 or 2 more, just because we don't want that to be north of the our x equals 0 line, our equator, right? And so, oh, that is like Desmos going, I can fit this real well, and you're going, no, you can't. Let's increase. You know what? 10 seems to work. That's good. To the 10th power. Yep, Desmos is understanding what we're saying. So it's got a great fit here. Oops, what happened? Plus, didn't bother Desmos. It's got a great fit, but we're just 11 and 11th power. So now, okay, so one of the problems might be some of my points might be a little too close. Like these guys, I might try to move this over. You know what? Yeah, so I went too far, so I'm going to need to add more points if I want to use this fit. Let's come back to here. Yeah. So what I'd really like is for this to go here, here, and then kind of taper off there. So I'm just kind of messing with these, seeing if I can get the function to fit a little better. It's interesting the different things these values do. Make that pull that way. So the points are only so good as they approximate the curve, right? So if it's not a good approximation, I want to improve that. Let's do this. Let's try adding. You know what? I think I want to go back, undo all that. Back to where I've got, I'm just hitting Control Z to undo this. Back to where I've got the, oh, I'm going to type all that stuff again. I made a bunch of tiny changes, didn't I? Undo. Sorry, oh yeah, every time you drag it, it moves. Okay, all right, well, I'll add these in manually. But you notice what you can do, you can keep adding this, and if it's jumping up and down too much, it means you don't have enough points. So you just need to increase the number of points. That'll make it more accurate. Eventually you'll get a good fit and a good curve fit. So this function here, which you could write out by hand if you want to, but this function is this polynomial here, right? And so what we're going to do is we want to integrate this function, integral, from starting from the leftmost side, that's the negative 0.67 that we talked about, negative 0.67, all the way to 1.736, that's the 1.75 we talked about. Now, one thing I'd like to do, there we go, I'd like to make that positive over in the corner there, just because I don't want, well, sorry, the integral here is going to be negative because it's below the x-axis, right? So we're going to integrate this, look at the area, and then flip it, right? So you can throw a negative in front if you want to. 1.728. All right. So integrate this function, and what you can do, you can actually copy and paste this. As I'm trying to show you guys shortcuts. You can copy and paste this, and we just want to delete the 7s below the x's because we're just interested in the same values. So Desmos remembers these values but is now calculating the integral over this function here. Almost there. Great. Now, one problem with integral, what does it say? We need to have a dx, right? Desmos doesn't like just having dx at the end there. You've got to tell it, oh, okay, put all this in parentheses, and close the parentheses here, and then it goes, oh, okay, great. So, this is let's see here, negative 1.989, and if I could, I can approximate, oops. Well, I approximate later, so that's going to be positive, right? So, I mean, I should flip this by putting a negative out in front. So that means this area here, the southern half or so of Walkersville, from whatever x-axis I selected, it's got a an area of 1.989. You can actually check this on Google Maps and find out if that is a good approximation, okay? So this is the first part of the project, and yeah, I hope you learned a little bit about how to use Desmos.